what you are seeing here is the ComputerCraft mod in Minecraft displaying the video that is showing on my monitor, so you can see the view I have in Minecraft be represented on the ComputerCraft monitor. And the way that is possible is like how I explained in the previous video on the topic about the conversion of the visuals into the ComputerCraft mod. I did not really explain it that how this is specifically possible, in that the ComputerCraft mod has all these computers in the Minecraft world, so for each computer you place down in the Minecraft world and you do something on those computers and you create files on the computers, all of those files are actually stored on the real hard drive on the host system, which means that there is a directory in the .minecraft/saves/ the name of the world / and then whatever the ComputerCraft directory's name was. In that directory, each computer you place down in the world where you do something has its own unique ID, and under that ID all of the files are there. So the computer's file system is actually on the actual file system of your host system, which means that the files can be modified outside of the Minecraft world, and like you can actually like go into the real system on your operating system where the Minecraft is running on. And the interesting thing about this is that, or rather the neat thing about this is that you can actually communicate with the ComputerCraft mod through this file system outside of Minecraft. So you don't need to communicate through Minecraft at all. You don't need to use some stupid APIs or any other nonsense. All you need to do is actually just interact with the file system. And what I did with this time is that instead of just having a series of images stored in the hard drive that the ComputerCraft computer then reads from its own directory and then displays on the monitor, this time I'm just going to read from a single file and display that on a screen continuously. So keep reading the same file and displaying it on the screen. But the thing is, I am modifying that file outside of Minecraft, externally, on the host's operating system. And the way I'm doing that is that instead of using the series of images, I'm now capturing the X11 screen and the X11 windowing system with ffmpeg. I have, since making that previous video, discovered ffmpeg, and ffmpeg is heckin' awesome. ffmpeg can be used to do anything, and I'm capturing the screen and then I'm piping that output from ffmpeg in the raw pixel data format RGB24, or actually I'm using BGR24, but it doesn't make a difference. All you need to do is just flip the R and B. But anyway, RGB24, BGR24, who cares? Anyway, output the raw pixel data, and then I pipe that into my own software program, the one I mentioned in the earlier speech. I explained how the color conversions work, except this time I modified it slightly, so that instead of reading a series of images from the hard drive, it now reads the input from the pipe on the Unix system. Unix pipe basically is the idea. So like, this is a GNU plus Linux system I'm using, but yeah, unix-like. So there's the pipe, so piping the output from ffmpeg to my software, and then my software does the conversion. It reads from the pipe the raw pixel data, does the image format color conversion stuff, and then writes that output into the file I mentioned earlier that the ComputerCraft mod computer continuously reads from and displays on the screen. So all the computer in the ComputerCraft mod in the Minecraft world is doing is it just reads from a file and displays that on the screen. That's all it does. So the ComputerCraft side of things is really simple. All it does is just reads the file and displays it on the monitor. So if you can do that, you can do that. It's not difficult. So yeah, that's easy. And then yeah, so all of the real work is done outside of Minecraft with the ffmpeg capturing the screen and piping the output into my software program. And I wrote it in C++. And yeah, so that's what that is doing. I did some slight modifications to the color mapping from the previous video. The colors were not quite accurate enough for my liking, so I modified them a bit. Oh, and also one thing I do want to add is I am using the a video filter in ffmpeg when I'm capturing the video. A video filter with a saturation filter, so I'm increasing the saturation. And the reason I'm doing that is because, well, as you know, the ComputerCraft colors, there are not that many of them. There's only 16, and they are also not the best colors. They are not very balanced, like I said earlier, not that balanced. Yeah, anyway, one could argue that there are actually two different types of cyan, if that light blue can be called a cyan. Not really, but you know. Anyway, it may or may not go in the same category. Anyway, the colors are not that good, but anyway, the biggest problem is that there are so few of them. Anyway, yeah, so mapping the colors, because you know, if you have 24 bits of color depth, then you have lots of different variations you can do, and that's a large color space to work with, so the content usually takes advantage of that. But if you try to shrink that down to just 16 colors, then a lot of those extremes get too far away, and the things that are not extreme kind of just blend together. So what I do with the saturation filter is I just push some of those mediocre colors to further extremes. So that's why the saturation, it better takes advantage of the color space, the limited color space of the ComputerCraft colors. So yeah, that's why the saturation. So increasing the saturation might help. Otherwise, things like grass look brown, because there's not really any good way of doing it, because if it's too desaturated, the colors are too close to each other, and then they all just become browns and greys and whatever nonsense like that. So that's why I increase the saturation, so that they are pushed further to the extremes. So yeah, increase the saturation, that's a good idea. Yeah, you don't want to have brown grass. So yeah, the way to solve that is to make things less brown and grey, which is to say increase the saturation. So yeah, without increasing the saturation, the grass would be turned to brown. But then, well, what if you said that well, instead of turning, well, what if I just mapped that value to green instead of brown? Well, then what happens is that actual browns also become green, and that's a problem. Actual browns should be brown, they shouldn't map to green. So the problem is that the grass just happens to be in that color range, where it just maps into the same area as the brown, so it becomes a brown. So yeah, there's no way to fix that by mapping that actual index to green, because that would then mean that brown things become green, and that's bad. So yeah, to make the greens actually green, just increase the saturation in ffmpeg. That way the saturation itself makes the greens more green. So then the greens just become green, they get mapped to the green colors naturally, without having to be mapped to the same area as the brown ones. So yeah, that's interesting and all, but yeah, isn't that a neat thing to see? Yeah, the Minecraft world, the picture on the monitor being seen in the Minecraft world on the ComputerCraft display. Yeah, I think that's pretty cool. So yeah, but like I said, it's not just the Minecraft view being drawn on the screen, it is the actual picture on the display. Like I said, with the ffmpeg does the X11 capture and then uses that as the input. But it doesn't also have to be that. It could be anything. So actually the interesting and neat thing about this is that it doesn't have to be the X11 windowing capture thing. It can be any file you have on your computer. You could display an actual movie. And this time it would be way better than the way I did it previously. Because previously I just had a series of images. There was a finite set of images that I converted in advance. So, and then displayed them in sequence, the specific sequence of images. I just displayed that on the screen. But what I did this time is that there is no finite set of images. There's no specified set of images. There's just a single frame buffer that it keeps rewriting and displaying on the screen. I mean, the ComputerCraft computer keeps displaying it on the screen, and the ffmpeg and my conversion program rewrite that file. So there's a single file that the ffmpeg and my software keep writing to. It just rewrites that same file over and over again, and the ComputerCraft computer keeps reading from that file and displaying it on the screen. So yeah, oh, and also I want to mention this. I symlinked that file to a RAM disk. So you can do this, for example, on the /tmp directory that is commonly mounted as a RAM disk, and I do encourage you to do that. /tmp should be a tmpfs file system. Well, fs is already a file system, but still. tmp file system, tmpfs. It's a good idea to have tmp as a RAM disk. So anyway, I put the file on a RAM disk so that I don't wear out my hard drive rewriting the same frame buffer over and over again. It would be quite useless and pointless to just keep writing that nonsense to the hard drive. Also, it does become slow and inefficient and all that stuff too. So it increases the speed and performance, but most of all, I just don't want to wear out the hard drive for no reason. So I put that on a RAM disk. So the actual file that the software program, the color conversion thing I wrote, that outputs to the RAM disk, to a file on a RAM disk, and then I created a symlink that, and then that symlink file I put on the Minecraft saves directory in the computer's file system. So yeah, that's pretty cool. Right. So yeah, because I did it this way, now there is not a specified set of images. It's not a finite set. It can play anything. Anything that you can capture input from with ffmpeg. Anywhere you can take input from. You can just pipe that into the color conversion program that writes to the RAM disk, and from the RAM disk through a symlink, the ComputerCraft computer reads the file. That symlink on the hard drive in the Minecraft saves directory, it appears on the ComputerCraft computer as if it was a file on that computer in the Minecraft world. Because the file system on the computer in the Minecraft world, it is actually a directory on the real hard drive on the host machine. So that's how that works. That's really good. So any movies, any videos, any kind of content that you could possibly pull the visual from, you can just put that into the Minecraft world. That's really good. Interesting, and yeah, that is good. Yeah, the way I did it the last time is I had a video file, and then I converted that file through some stupid online video conversion service to a series of PNG images. That was kind of silly. ffmpeg could do that easily, but I was not yet aware of the existence of ffmpeg back then when I made the last video on the topic on the ComputerCraft monitor video things. I did not yet know ffmpeg existed, but I have since discovered it. And ffmpeg is really awesome. So, ffmpeg it is, and that does what is needed. It can set all the resolutions. Oh, and by the way, the correct resolution, the highest resolution possible, is 164 by 81 with the text cursor size thing set at 0.5. And that is the resolution here with 16 colors and a small frame rate. Right. And that's it for this video. Thanks for watching. Until next time, bye.